So just take a second and think about your typical workday. You probably check a CRM like HubSpot, maybe jump onto a Zoom webinar.
Oh, absolutely. And then you're checking a Facebook ad campaign or sending out some email blasts.
Exactly. I mean, you individually are generating thousands of data points every single day. But if your boss walked in right now and asked you to trace a single customer's journey across all those different apps seamlessly, could you actually do it?
Yeah, for the vast majority of companies, I mean, the answer there is a terrifying, flat-out no.
Right. Welcome to Dataverse by Nina Hall. I'm so excited to get into episode number 38 today, and the topic is a heavyweight unified cross-platform intelligence across 20-plus data sources.
It is a massive topic. I mean, it's essentially the defining operational bottleneck of the modern digital business. We have more tools than ever, but, way less clarity.
Yeah, exactly. And the reason this matters so much to you, the listener, is because we all live in this entirely fragmented digital ecosystem. But the second you try to get these platforms to actually talk to each other, to give you a single clear picture of what's happening, it turns into a total nightmare.
Because the data is completely siloed. You end up with a dozen different systems giving you analytics, and, well, none of them agree with each other.
Which is exactly why we are jumping straight into a really fascinating case study from Nenopal today. So they partnered with this leading media company in the dental industry to untangle this exact nightmare.
Yeah, and it's a great example to dig into.
Our mission for this deep dive is to really strip away the buzzwords. We want to uncover exactly how you take fragmented data from over 20 completely different systems and actually engineer them into a single automated source of truth.
And I think to appreciate the mechanics of the solution, we first need to look at the sheer scale of the mess this dental media company was facing.
Oh, it was a mess.
Right. When we say 20-plus platforms, we are not talking about some obscure little tools. We're talking about the core foundational systems holding their business together.
Yeah, looking at the source list, it reads like a completely standard modern tech stack,
Yeah.
just, entirely disconnected. You've got Facebook ads, HubSpot, MailChimp, Digital, Zoom.
Plus YouTube, Google Labs, LinkedIn, SurveyMonkey, SendGrid.
And a Moodle-based learning management system for all their educational courses, right? Okay, let's unpack this. It's like trying to bake a cake, but your ingredients are locked in 20 different supermarkets, and half the store managers speak completely different languages.
That is a perfect way to describe it. What's fascinating here is why this fragmentation actively stalls business growth.
Right.
Because every single one of those platforms generates incredibly vital behavioral data. But, in isolation, the value of that data is totally capped.
Because cross-platform attribution is basically impossible, right?
Right.
Like they could see someone clicked a LinkedIn ad, and maybe later they see someone bought a course in Moodle.
Exactly. But mathematically proving that was the exact same person on the same journey, I mean, that's a total guessing game without a unified layer.
And they were just relying on manual exports, weren't they?
Yep. No data warehouse at all. They just had a team physically downloading CSV files every week, trying to mash them all together in giant spreadsheets.
Oh, wow. That sounds awful.
It is, but it's remarkably common. And think about what that means for strategy, right? By the time an analyst downloads all that data, cleans it, lines up the columns, and builds a pivot table, that intelligence is already a week old.
So you aren't making data-driven decisions. You're just making, spreadsheet-driven guesses based on old news.
Precisely. If you can't see the whole marketing funnel in one place, you just can't optimize it.
So hearing this, anyone with a basic understanding of modern software is probably asking the obvious question here.
Why not just plug them all together?
Exactly. I mean, we live in the age of APIs, right?
Yeah.
Aren't APIs supposed to be these magical, standardized bridges between software? Like, why couldn't they just use native, out-of-the-box connectors for everything, grab the Zoom API key, plug it in, and you're done?
Yeah, that is the exact trap so many organizations fall into. There's this pervasive illusion out there that integration is just easy now.
Because that's what the marketing brochures tell us. Plug and play.
Right, plug and play. We assume an API is just a universal translator, but the raw reality of data engineering at this scale is, it's unforgiving. An API is just a set of rules, and those rules are defined by whatever specific team built that specific software.
And every team builds differently.
Exactly. There's no universal standard for how data should behave. This case study really highlights some brutal platform quirks that just shatter those native connectors instantly.
Right, like take Zoom events, for example. Millions of people use Zoom. You'd assume their data pipelines are just super straightforward.
You'd think so. But the source notes show that Zoom events had completely broken pagination behavior.
Okay, wait. For those of us who aren't software developers, how does pagination actually work in this context?
So when you ask an API for data, say, give me a list of 10,000 webinar attendees, the server doesn't just drop a massive gigabyte-sized file on you all at once.
Right, that would probably crash the connection.
Exactly. So instead, it sends the data in pages, kind of like a physical book. It hands you the first 100 records, along with a digital bookmark that essentially says, here's the token for page 2.
Okay, makes sense. You request page 2, get the next 100, and so on.
Right, until the API's internal logic just totally fails. With broken pagination, your automated pipeline might ask for page 2, but the server hands it page 4.
Oh, wow.
Or it gets stuck in an infinite loop, just giving you page 1 over and over again. If you rely on a standard native connector there, suddenly your attendee database has 5,000 duplicates of the exact same person.
And you completely miss the other half of your audience, so the plug-and-play bridge just immediately collapses.
Exactly. You have to actually build custom engineering logic just to read the pages in the correct order.
Man. And Zoom was just one hurdle. The integration also ran into YouTube Analytics having OAuth account mismatches. Let's pause on that. What exactly is an oath mismatch?
So OAuth and authorization is basically the standard security protocol that lets an app access your data without needing your actual password.
Like when a pop-up says, grant this app permission to view your YouTube data.
Yes, exactly. A mismatch happens when the access token you generated belongs to, say, a personal admin email address, but your automated pipeline is trying to query the corporate brand channel.
Ah, okay.
The API just rejects the request, and the entire pipeline fails silently.
Fail silently. So you think everything is flowing perfectly, but the pipe is just totally shut off.
Exactly.
What about the ad platforms? I noticed Google Ads was mentioned as a major pain point.
Yeah, Google Ads has this huge multi-account ingestion complexity. When a big media company manages ads, they don't just use one simple account. They have an umbrella manager account, and then underneath that, dozens of nested sub-accounts.
Right, for all their different campaigns and divisions. So you can't just send one request asking for all the ad data.
Nope. You have to write a custom orchestration script. It has to first ask for the entire account hierarchy, memorize that map, and then iteratively loop through every single sub-account to pull the metrics.
Wow.
And then it has to tag where that data came from before moving to the next one. Out-of-the-box tools just totally fail in that maze.
Which brings us to the biggest maze in this entire tech stack, HubSpot. The sheer scale of the CRM data here was just massive.
Well, HubSpot is the central nervous system for a business like this. Contacts, deals, call logs, emails, tasks. I mean, we are talking about hundreds of thousands of individual activity records for this client.
And the massive roadblock here is that HubSpot's API has a hard 10,000 record limit for certain types of extractions.
Yeah. And this is where data engineering really becomes an exercise in pure precision. You have 500,000 records you need to move, but the doorway you have to pull them through only lets 10,000 pass at a time.
What happens if you try to pull 10,001?
The API just throws an error and drops the connection completely.
So how do you actually get the data out without breaking the system?
You have to design incredibly precise backfills and date range splits. You can't just ask for everything. The orchestration layer has to dynamically slice the requests by time.
Like down to the minute.
Exactly. It tells the API, give me all the records created on January 1st, just between 8:0 a.m. and 8:1 a.m. It verifies that payload is under 10,000, pulls it, saves it, and then shifts the window to 8:1 a.m.
That requires incredibly tight logic.
Yeah.
Because, I mean, if you mess up the time windows even slightly, you either miss data entirely or you pull the exact same data twice.
Right, which is why you have to have heavy deduplication logic. When you pull data in overlapping chunks to be safe, you will inevitably capture the same record twice. If you don't filter that out before it hits your database well, your reporting is completely ruined.
Okay, so this firmly establishes that native connectors are just entirely off the table for an enterprise this size. Getting all this stubborn data out required a custom, multi-tiered compute architecture.
Right.
The solution here used a layered approach to orchestration, relying heavily on a platform called Make.com.
Yeah, Make.com is a fantastic low-code automation platform. It's really great for visual orchestration. For this, they used Make.com scenarios featuring HTTP modules to automate the weekly ingestion.
Let's define HTTP modules really quickly for the listener.
Sure. So instead of relying on make.com's pre-built buttons for like Facebook or MailChimp, an HTTP module lets the engineer write a custom raw web request. It gives you total control over the authentication, the headers, the specific API endpoint.
And the goal there was to capture the raw JSON payloads, which, for anyone unfamiliar, JSON is basically the standard digital shipping container for web data. It uses brackets and text, so completely different computers can read it.
Exactly. And make.com was highly effective for grabbing those JSON payloads across the majority of these 20 platforms.
But here's where it gets really interesting. Getting the data out of that Moodle-based learning management system completely broke this low-code approach.
Oh, entirely.
The source mentions Moodle required a deeply nested API execution. Walk us through what a nested API workload actually means and why make.com just couldn't handle it.
Well, in a standard API interaction, you ask a single question, you get a single answer. You say, give me a list of all new users, and it hands you a list. One call, one response.
Super simple and efficient.
But a nested API forces you to ask follow-up questions for every single item inside that first answer. With Moodle, the pipeline couldn't just ask for global user progress.
Right.
First, it had to ask, give me a list of all the educational courses.
Okay, so let's say they have 100 different dental courses.
Right, so the pipeline gets that list of 100. Now, for every single one of those 100 courses, it has to loop back and ask a second question, who are the enrolled users in this specific course?
So we just jumped from one API call to 100 separate API calls.
And it gets worse. Let's say there are 50 students in each course. Now the pipeline has to do a third loop, asking for every single student in every single course. What is the detailed completion status for the specific user?
Oh, wow. Doing the math on that, you went from one initial request to 100 to 5,000 separate requests just to get one daily progress report.
That's the multiplier effect of a nested workload. It grows exponentially. And when you try to run thousands of exponential operations through a low-code platform, you hit two massive walls. First, execution timeouts.
Because low-code tools are built for quick tasks, right?
Exactly. They will just time out and crash if a process runs for hours.
And the second wall has to be the cost.
Oh, the credit consumption would be completely astronomical. Low-code platforms charge you by the operation. You would blow through your entire monthly automation budget in a few hours just asking Moodle for completion statuses.
So what's the technical pivot there? How do you bypass that limitation?
You have to graduate to cloud-native compute. The team basically stepped away from make.com entirely for this one task. They spun up a custom Python-based Google Cloud Run service dedicated solely to Moodle.
Basically building a custom micro application that just lives in the cloud to interrogate the learning platform.
Exactly. By using Python on Google Cloud Run, they had total control, which meant they could implement progressive inserts.
Progressive inserts. Meaning what exactly?
Well, instead of trying to hold 5,000 responses in the server's memory and writing them to the database all at once, which could crash it, progressive inserts write the data in continuous little manageable chunks.
While constantly bookmarking the progress.
Right. So if a network blip drops the connection at record 4,999, the script doesn't have to start over from zero. It resumes exactly at 5,000.
Okay. That is incredibly robust.
Right.
So between the HTTP modules in make.com and that Python script in Google Cloud Run, the extraction problem is solved. The data is liberated from the 20 platforms.
Yep.
But dumping 20 different flavors of raw JSON files into a hard drive doesn't magically create a source of truth. It just creates a digital landfill.
Exactly. If you stop at extraction, you haven't actually solved the reporting problem. You can't analyze a customer's journey if one platform formats dates as text and another formats them as integers.
So to give this massive influx of data actual structure, they used Google BigQuery as the centralized data warehouse, and they applied a very specific three-layer architecture to process it. Let's break down this assembly line. The first layer is called raw.
Yeah, the raw layer tables just hold the immutable JSON payloads exactly as they were extracted. You never alter, clean, or edit anything here.
Why keep the messy version? Why not just clean it immediately?
Because if a transformation rule breaks downstream, or if your analyst questions a metric 3 months from now, you always need to be able to audit exactly what the API handed you on that specific day.
It's your ultimate backup. That makes perfect sense. So from raw, it moves to the staging layer. This is where the heavy lifting happens, right?
Yes. Staging is where data is standardized. The JSON is parsed out into actual columns and rows. It handles deduplication, and crucially, it handles typecasting.
Let's make typecasting concrete for a second. What does that actually look like?
So typecasting is explicitly defining the structural category of your data. Let's say Zoom sends a webinar timestamp formatted as text like July 24th, 3 p.m.
Right.
But HubSpot sends its timestamps as a UNIX integer, which is just a massive string of numbers representing the seconds since 1970.
A database can't compare those two things at all.
No, it would immediately throw an error. So in the staging layer, you typecast both of those completely different inputs into one standardized SQL timestamp format. You force all systems to speak the same mathematical language.
And you clean up messy text inputs here, too.
Exactly. If someone types their email with a leading space, staging strips the white space and forces it to lowercase so it perfectly matches the CRM.
It's like the ultimate prep kitchen. And once it's parsed, cleaned, and typecast, it moves to the final layer, the mart layer.
Right. The mart views are the plated meal. This is where you join the clean tables from all 20 platforms together into reporting-ready datasets. This is the only layer your analysts or visualization tools actually interact with.
But inside this BigQuery architecture, there was one specific piece of transformation logic applied to the HubSpot data that I found amazing. It's called Slowly Changing Dimension Type 2, or SCD Type 2. And they used it specifically for tracking deal stages.
Oh, it is a phenomenal mechanism for preserving behavioral data.
Wait, I have to ask you about this because it seems overly complicated at first glance. So SCD Type 2 involves creating a valid from and a valid TIO timestamp every single time a deal changes status.
Right.
Why wouldn't a database just overwrite the old CRM data? Like if a deal moves from prospecting to closed won, just update the column to closed won and save the storage space, right?
It sounds efficient to overwrite.
Right.
But if we connect this to the bigger picture in the realm of business intelligence, overwriting data is actually destroying data.
Because you're destroying the historical context.
Exactly. If you simply update the field to closed won, you know exactly where the customer is today. But you have completely erased the story of how they got there.
The old status just doesn't exist anywhere anymore.
It's gone. How many days did that deal sit in prospecting? Did they move to negotiation, get cold feet, bounce back to evaluation, and then finally close?
If you overwrite it, that behavioral zigzag completely vanishes.
Exactly.
So how does SCD Type 2 prevent that?
Instead of updating a row, SCD Type 2 inserts a brand new row for every single change. It uses those valid from and valido timestamps to track the lifespan of that specific status and adds an isCurrent flag.
Okay, I think I see it. It's like the difference between just seeing a photograph of the finish line versus watching a video of the entire race.
That is the perfect analogy. SCD Type 2 essentially builds the time machine. You can query the database and ask, what exactly did our sales pipeline look like on the second Tuesday of last November?
Wow. Because the history was never overwritten, BigQuery can reconstruct it exactly as it was.
Right. It allows leadership to analyze velocity trends, see where deals are getting stuck, and truly understand the friction in their sales cycle.
That is incredibly powerful. Bringing this all together, the transformation for this dental media company was just massive. I mean, they started with 20 disconnected platforms, manual CSV exports, zero cross-platform visibility.
Total chaos.
And through this combination of make.com orchestration, custom cloud-run microservices for the nested APIs, and this three-layer BigQuery architecture with a built-in time machine, they completely altered how they operate.
Yeah, the immediate operational impact was 100% weekly pipeline automation coverage across all those platforms. The manual data exports were just eliminated entirely.
Meaning stakeholders wake up to reliable, refreshed insights without anyone lifting a single finger.
And strategically, they finally achieved complete cross-platform attribution. Because all that standardized data now lives in the mart layer, they have end-to-end visibility.
So what does this all mean? They can finally connect the dots, right? They
Yeah.
can definitively prove that a user clicked a LinkedIn ad in January, attended a Zoom webinar in February, completed a Moodle course in March, and then became a closed-won deal in HubSpot in April.
Exactly. It maps the entire life cycle. And furthermore, by investing in this extensible cloud-native architecture, they established a foundation for the future.
Right, because this clean historical data warehouse is exactly what you need to support advanced predictive models or AI-driven insights down the road.
Because AI is completely useless if you train it on a digital landfill. It needs that structured mart layer to actually find real patterns.
Exactly.
Data is really only valuable when it's understood holistically. For years, this client had immense intelligence just trapped inside those isolated platforms. This infrastructure finally gave them the mechanism to unlock it.
It is truly a masterclass in modern data engineering. Well, as we wrap up this deep dive, I want to leave you, the listener, with a final thought to mull over.
Oh, that is a good one.
We talked about all the different apps you use in your daily workflow. Think about your own digital footprint right now, or the specific software stack your company relies on. If an AI could perfectly stitch together the 20 platforms you use most without losing a single piece of history, utilizing that time machine logic we just explored, what surprising or perhaps uncomfortable truth would it reveal about how you actually spend your time and operate?
That is a fascinating question.
Something to think about. Thank you so much for joining us on Dataverse by Nino Paul. We will catch you on the next deep dive.